Today I'm going to be discussing the ecological impacts of light pollution and the impact of a switch from traditional street lighting to LED street lighting. I'm going to begin by just explaining a little bit of background about this topic. In the UK there are currently 6.5 million streetlights, with the majority of these being your traditional high or low pressure sodium lamps, easily recognisable by their dull yellow or orange appearance. However, over the last decade, there has been a rapid development of LED street lighting. Since 2016, the UK government has spent £490 million on LED lighting. So why is the government investing so heavily in this? They are between 40 and 60% more energy efficient, whilst providing better quality lighting. Therefore, these require less energy and improve street safety. The light emitted is brighter and whiter in colour compared to sodium lamps, and the reduction in carbon emissions from a total switch to LEDs is equivalent to removing 8.5 million cars from the roads. This sounds fantastic, right? However, an often ignored side effect of LED lighting is the increase in light pollution, which is actually one of the most rapidly increasing types of environmental degradation, with a 6% annual increase. When I say the term light pollution, I am referring to light levels produced by artificial light that are higher than the natural nocturnal lighting levels provided by the moon and stars. This phenomenon is typically associated with urban environments due to the high density of bright lighting. This issue is only expected to grow in the future, as by 2050, the amount of people living in urban areas is expected to rise from 44% to 68%. This will cause cities to expand and sprawl, meaning areas previously naturally lit will suffer the effects of light pollution. So what are the largest impacts on land-based ecosystems? The switch to LED street lighting threatens biodiversity and ecosystem services due to declining insect populations. A 2014 study found that insects were 48% more attracted to LED lights than high-pressure sodium lamps. This is because LEDs have a greater relative intensity from the blue-green section of the electromagnetic spectrum, which attracts insects. This affects natural patterns of insect behaviour, such as reproduction and pollination. They are also more susceptible to predators such as bats, as there are large concentrations of insects in a small area, making them an easier target. You may be wondering why a declining insect population is such a large issue. Well, insects are essential for a healthy ecosystem and sustaining biodiversity. They are responsible for conducting a wide array of ecosystem services, including seed dispersal, pollination, decomposition, and water filtration. In short, without insects, ecosystems as we know them cannot exist. Light pollution also impacts wild plants. The process of photosynthesis transforms energy from light into energy used for growth. Artificial light pollution from LED street lamps is bright enough to induce a physiological response in plants, affecting their growth and resource allocation. The areas most affected by this are frequently illuminated habitats such as roadside verges and urban ecosystems. This causes a disruption of the natural diurnal cycle, leading to increased photosynthesis. Again, you may be wondering why this is a problem if more photosynthesis is occurring. Disruption of natural light cycles causes the retention of leaves of deciduous trees into the winter. Although this may not initially seem like an issue, the time leaves open and fall is imperative for the health of a tree. If the leaves open a few weeks early or even close a few weeks late, they can become exposed to damaging frost, which damages their photosynthetic tissue. Additionally, when flowers open early in spring, they are at greater risk of exposure to fungal pathogens, which can lead to disease. The disease can then spread amongst these and cause large-scale dieback of trees and plants. An often ignored impact from light pollution are the effects on marine ecosystems. The sky glow generated from light pollution from major cities can extend 100 kilometres. Worldwide, more than 1 billion people live within this distance of a coastline, meaning an estimated 354,000 kilometres of the world's coastlines are exposed to artificial light pollution. The main sources of marine light pollution come from land-based developments such as towns, cities and harbours. However, offshore oil platforms and shipping also contribute. So what is the impact of these sources of light pollution on marine ecosystems? The vast majority of marine species have evolved under natural and predictable cycles of daylight and nighttime, and these define whether species are nocturnal or diurnal, offer a useful navigational aid, and help to coordinate reproductive events. A well-documented impact of light pollution is the disorientation that artificial light causes species who rely on the natural light cycles to navigate. Sailors often experience bird strikes with ships, often by whole flocks of seabirds which have become disorientated by their lights. Coastal light pollution has a particularly large impact on sea turtle hatchlings who use the moonlight in order to walk from their nests on the beach to the sea. Street lamps and other forms of artificial lighting disorientate turtle hatchlings, which delay or even prevent them from entering the sea, leaving them more exposed to predators. If these hatching sites become unusable due to the light pollution, then populations will decline further. LED light pollution also impacts marine bioluminescent creatures, such as krill and squid, who emit light from their bodies to either avoid predation or lure prey. Anti-predator strategies include using light displays to confuse predators. Traditional high and low pressure sodium lighting technologies have not impacted this due to the narrow spectrum of light emissions. However, LED lights emit light at a broader spectrum, which does impact bioluminescent creatures. The extent and ways in which this will impact this aspect of the marine ecosystem is unknown, but will be experienced in the future as there is a continuing shift to LED lighting. There are potential solutions to reduce the ecological impact, such as installing LED lights with long-pass filters, which narrow the spectrum of light emissions, which reduce the impact on the attractiveness of insects and the impact on bioluminescent creatures. But the trade-off of these is that they reduce the quality of light emitted and their efficiency, which defeats the initial objectives of installing these in the first place. Thank you very much for listening to this podcast.